Hi, I'm fatdino and I'm addicted to video games. My favorite games are action RPGs. I generally spend thousands of hours in games like Path of Exile and Diablo. I love action RPGs so much, I just have to try and make my own. Today, I wanna share my first steps of making a 2D loot-based action RPG game codenamed Tower. The game takes place in a dark world, where you are playing as an outlander trying to investigate mysteries of a tower in a village abandoned by gods. While climbing the tower, be ready to kill countless monsters and get some nice loot. I will be using Sprite for everything pixel art and Godot with GDScript as my game engine of choice. To start with, I have some very basic features like movement and collisions already implemented. I also made some pixel art environment pieces and this character just for showcase purposes. In this devlog, I wanna focus on two essential systems: level generation and pathfinding. Procedural level generation can be extremely challenging, so it was really important for me to lay the foundations. It's not uncommon to use separate level generators for different things: open terrains, dungeons, villages, and so on. But luckily, I don't have plans to generate vast open terrains. The key thing I need is a dungeon-style level generator. I have made several constraint solvers for dungeon generation in the past. I didn't find them particularly promising, so I never really finished to build any of them, but you can see some of the results on the screen. The thing I really want to talk about though is the algorithm I am using now. Let's start from a big square, then divide it on smaller room-like rectangles. Now I will mark one of them as a start room and another one of them as an end room. End rooms can contain stuff like bosses or passages to the next level. Let's assign every room a random weight and pass it to any pathfinding algorithm to find a path from start room to end room. Now, following the path we found, we can start filling empty rectangles with actual rooms. Room doesn't necessarily have to have the exact shape. Any room will do, as long as it fits into appropriate rectangle. You can even use separate generator, specifically to procedurally create such rooms. But I am using pre-made rooms and randomly choosing which one to use, depending on shape. We can spice it up, adding additional random rooms, or even go as far as running a pathfinding algorithm again to find more paths to the end room or any other room. Let's add some basic art for floor and walls. Right now, I have only few very basic rooms, and even with that, I can generate a lot of variations of a single level. To make things look a bit more natural, I added a second generator pass, which adds sort of dead-end rooms. By design, there is always a path between any two rooms in the level. A path which was used to generate rooms can be helpful to generate doors or passages between rooms. It doesn't always show you where the door exactly should be, but it gives you a very good idea, until it's not, obviously. Next logical step is to fill all of the generated rooms with anything really. There really are a lot of ways to fill a room with all sorts of furniture and decorations. For now, I simply have several pre-made groups of decorations I choose randomly from, and then I pick a random subset of objects from a single group. That means I have to place decorations and design every room myself, which is a deliberate choice. These are some variations of a single generated level. I can also change input to generate more narrow levels. A huge variety of possible levels will come later, when I will have a bunch of different tile sets and all sorts of objects I can use to build different rooms for a generator to use. Second big goal of this devlog is to get pathfinding up and running. Any entity, enemy or friendly NPC in town should be able to traverse game world. Usually pathfinding in games is reduced to a graph search. I will represent game world as a number of identical grid cells connected to each other. Green ones can be walked on and reds are obstacles. Now it is trivial to make a graph based on these cells and run a simple A* to find the shortest path for monsters or NPCs in town. A bit more complicated task is to construct a graph which represents procedurally generated level. To start off, I will add a partial graph to every pre-made room I have. Then, when room selected by a generation algorithm, I can stitch these small parts into one big graph. Connections should be located in the places where doors are generated. Once we have one big graph, we can pass it to A* to find the best path between 2 points. Considering the nature of the game, currently almost no optimizations are needed, since monsters will start pathing to you only if you're close enough and in line of sight. It's basically guaranteed A* will find a path in no time. Moreover, I can make all NPCs inactive and don't process them at all, activating only monsters that are close enough to player. I can have several hundreds of monsters in the level with no real impact on performance. Currently, I don't have any avoidance for monsters while they are chasing player, but I did make it so monsters will try to surround player they are attacking. By simply increasing weight of the cell, attacking monsters are staying on. Now when I have basic monsters with pathfinding, I can focus on much more interesting thing: combat system. It is definitely a topic of a separate video though. So leave a like if you enjoyed and let me know in the comments if you have any feedback or questions. I will do my best to answer them. Feel free to follow my socials with the links in description and hit me up there as well. Thanks for watching, and as always, see you next time.